Hello guys, this is Nex and this is the beginning of my tutorial which I would like to do while I'm actually trying to program for myself a kind of a terrain generator, terrain editor. And this, while I'm programming it, I will also step by step make a tutorial about what I'm doing. And this tutorial will be about C# programming and using the DirectX API. And for the first tutorial I was thinking I'm gonna make a plain setup of the whole DirectX settings, what I need, and draw a very primitive triangle. It will then look like this. We have a triangle in a three-dimensional room using my Windows form. And let's start right along. First of all, you need to download actually the Microsoft DirectX SDK. You'll find it simply by typing in DirectX 2010 SDK, click on it, download it over here. This is the version 9 point something, and it's plain DirectX. It's the original wrapper for Visual Studio, so we can program with it. The only disadvantage is that it doesn't support the latest DirectX versions. For that we would need some other third-party wrappers such as SlimDX or SharpDX, or also we could simply program with X and A, but we're not gonna do anything over here. We just use the original DirectX, and that's what we're gonna do. First of all, let's start a new project, and we call it terrain generator tutorial 0.1. Very important here is already that we select a framework not higher than, I think, 3.5, but I'm gonna stick with 2.0, so don't choose anything higher, I think, than 3.5. We select the Windows form and we open it. Let's set up the form a little bit bigger. Let's change the size, then the text, terrain generator tutorial. I can also set up the start position to center, and that's it. To be able to work with DirectX now, we need to actually, in English it's called references, implement some references. As soon as you have downloaded the SDK and installed it, you can go and search for it. It's in the folder C, Windows, Microsoft.NET, DirectX for Managed Code. And if you go in there, you have a couple of folders. Just select the highest, or just select one of these things. We just use this one. Let's use Microsoft DX. Actually, it's not the latest. This one is the latest. No. So we need, Okay, now let's just select the first one, 2902.1029.020. Here we will find DirectX, Direct3D, and Direct3DX. These three libraries we're gonna need. You click on bringing them into adding them. Select them here because I have them already. Okay, now the references are here and we can use them. The next step, DirectX won't work here now because DirectX doesn't support a 64-bit application. I mean, the latest one does, but this version does not. So we have to click on Properties and go on Build. And here on any CPU, we change it to x86 to go actually with a 32-bit program only. Yep, we can close this. And now the form is kind of ready to use. Let's check out the code. And here we're gonna do all of our programming. The first thing, of course, we need to bring in the libraries using Microsoft.DirectX. Then using Microsoft.DirectX.direct3D. These are the two things which we're gonna use. And then, yeah, we need a couple of things over here. The first one, which we will need, is we need to set up our window. This is a Windows form, and we would like to draw or to paint or to create our three-dimensional DirectX world in this window over here. And there are a couple of options which we have. One option would be actually to select the panel, bring it over here, maybe dock it even somewhere or whatever. And we could choose this panel to put all of our DirectX programming into, kind of. This would be interesting if we would like to still use the form all around to create some menus and whatever, and have one window in the middle which shows our DirectX rendering. Yet we're not gonna use this for this project. I simply use the whole form itself, and yeah, we need an event, and we look for the event paint. The paint event will be always when the window is being painted, it will execute this event. So we create a new event, I double click into it, and here it is. The event is already added. And now we would like that we need to still set up the window itself, that whenever, as soon as the application is running, that it refreshes itself constantly to somehow create a loop, you know. And therefore we have a very, very neat function. It's super sweet, and it's called this invalidate. As soon as we call this function, it simply invalidates the window, and as soon as it's invalidated, it's painting itself, and so it comes back into the paint event, and at the end of this event it comes down to invalidate it again and over, and so we have kind of an endless loop, which means the window form will be painted, yeah, depending on the frames per second. It's just refreshing itself constantly. But that this actually works the way we want, we go up here in the public form, and we need to set the style for this. There is a set style, and yeah, the control flags which we're gonna choose here, control flags is all paint in WM paint, and we also gonna use the control styles opaque. Here it is, and the second parameter is set on true. So as soon as we have this, whenever we open the form, it automatically creates a loop, and actually this loop is exactly in here. Whatever we write in here will be painted and redrawn. So yeah, that's it. Okay, there is a little error. We're gonna come to that later. Wait. What did I forget? Oh, here. Yeah, we see already the form. It's flickering a little. And something is actually happening. So, yeah, that's everything actually so far which we need to set up from our Windows form, you know, and now we can go straight forward to using DirectX to actually put in here some information. And yeah, the first thing which we will do is we set up some variables, and the first and most important variable is the device, private device. We call it device. Set it to null over here. The device is the main object which we are using throughout everything. Into the device we put all our information, and then we just tell the device to present itself into that Windows form, and then it just puts everything there. So the device is the main object we are working with. The second thing which we're gonna need is actually a buffer. We're gonna use here just a Vertex Buffer. It's a very nice Vertex Buffer. It's a very nice tool to simply store some vertex information. A vertex is nothing else but a dot in our three-dimensional room, some position in our three-dimensional room. This is a vertex, and later on we can connect these vertices to make a triangle, or even a lot of triangles for a whole terrain. And yeah, let's just paint one single triangle. Therefore we need 3 vertices, and these vertices will be then stored in our vertex buffer. We're gonna set this up later. So as I already said, the vertices, custom, we go here, we have the custom vertex class, and in that we find a couple of options. I would like to make an array of vertices now, and therefore I choose the first thing here. It's called position colored. It simply stores a position information and a color information into one of these vertices. Other options would be, for instance, here, position normal. It would store a position data plus the normal vector towards this position. This would be necessary if we want to implement some light or make a real-time shadow calculations and all this kind of stuff. Yeah, also texture, position and texture is possible. It has a position information, and it also has the information of where and how the texture has to be placed from each vertex, plus a combination of all 3. Okay, we stick with the position colored, and we want to have an array of that, and we call it verts, and we initialize it also later. So yeah, these are the three variables which we actually gonna use. We have set up the window so far, and now we add some more functions and actual methods. The first one, private void, will be some initialization of graphics. Initialize graphics. In here, we're gonna initialize our device and everything, but before we can actually initialize our device, we need to set some presentation parameters. Present, where is it? Present parameters, we call it PP, new present parameters. And here we can set, for instance, windowed is true. If this is true, we have a window form. If this is false, we would have a full screen presentation. Okay, and now one more thing which we need to define is the swap effect. The swap effect is simply it sets how the memory, the information which is stored in the back buffer, is actually put into the front buffer. The front buffer is kind of what is displayed on your screen, and the back buffer is something in the background. And everything which we put in is calculated and somehow drawn, I think, somewhere in the back buffer, and how this whole information will be put into the front buffer. And we totally let Direct 3D, one of the components of DirectX, do the whole job by itself. So we just simply select here discard, and as our option. Okay. Now the present parameter is actually set. Now we can initialize or actually set up our device. Device is new device. We have a couple of possibilities here. We're gonna stick with the third one. Adapter. The first one is, yeah, this device is the default device, that's why it will be 0. The second one is device type. Device type, we have also some options. We just stick here with hardware. The third thing is the control render window, and this over here is where we tell where the device actually has a control over, where it kind of paints into. If you would like to draw all your DirectX stuff into one panel, as I explained earlier, then you would need to tell the device over here to use that panel. But because we use the whole form, we just use this, then create flex. We have also different options. I don't want to go into detail. Some option would be software vertex processing, which would do all the calculation kind of on the software, or the hardware vertex processing. This is the better way to go if your graphic card is actually able to, or it's supporting the hardware vertex processing. If your graphic card is doing that, then it will do that, and it will be instantly a performance increase. Actually, totally doesn't matter for us. We could go with each way, software vertex processing or hardware vertex processing. Let's just go with hardware vertex processing, because Okay, and what's the last thing? Yeah, the presentation parameters. That's why we had to set it up earlier. And here we go. That's our device put up. And yeah, then the device is now set up. The next thing will be the Vertex Buffer. Therefore, Vertex Buffer is new Vertex Buffer. And yeah, here we also, what we're gonna use, yeah, something, I don't know, which one type of, yeah, okay, here it is. We need to first type vertex type, and we need to tell him what vertex types we would like to put in, and we have this kind of vertices, which are this custom vertex position colored. And so type of custom vertex, custom vertex position colored. That's it. As the first, then the second thing will be the integer of the size of buffer in bytes. What does this mean? Simply how many vertices would we like to store in there? How many points would we like to store, due to the fact that this array will be later set to 3, the size of 3, because we have 3 edges of a triangle. A triangle needs 3 spots to define it. The way to go here is 3. Then, yeah, the usage, we're gonna, no, first the device. We're gonna set the device first. Why is it showing us this one? Okay, so here we have the device that we use for this vertex buffer. It's linked now with our default device. So, and now the usage. Usage dot, we want to have a dynamic use, which means that we actually can later on, once data is stored in the vertex buffer, we can actually alter it, we can override it, and so on. So we just set it on dynamic, and additionally usage write only. Okay, and what's the next thing? Custom vertex. Here we need to set actually the position colored, the format. I guess this will, he will not like it because an assembly is still missing. And the pool, I just take the default. Okay, yes, I thought. Yeah, let's just add it. Okay, yeah, I just added the reference to the assembly by clicking on it, and it should work like this. Okay, the next thing, we would like to do something once the vertex buffer is created. Once we create it, like this buffer, we created now a memory, so to say, which is able to store some vertex informations. And once this is created, we actually want to fill it. So we simply create an event handler. So vertex created, once it's being created, yeah, we would like to do as new event handler, and yeah, therefore actually let's create it first. What do we need? Private private void how do we call it, on Vertex Buffer create, then we have object sender and event arguments, go on here, event arguments E. Okay, and this is what we're gonna use. This cool, and may also open it over here with, we give it the vertex buffer, and we have no arguments, so this one is set to null. And set to null. What am I doing? So, okay. And the last thing is, on create, it will go down here, and here we're gonna put all the information into our vertex buffer, and once it's set, the information is there, we kind of have to put it onto the vertex buffer. So vertex buffer set data, that's how we store now things into our vertex buffer. Therefore, the vertices we're gonna put over here as the data. Locket offset, we start at 0. So from the very beginning, we don't wanna store something only once we have hundreds of vertices. We don't wanna just lock some of them and start writing somewhere in the end or in the middle. Only we start at the very beginning of the buffer. That's what we set over here. And log flags, we just simply set to none. What the hell? So yeah, that's it. Set data. We need to actually generate this data, and that's what we're gonna do in our on vertex buffer create. Yet first of all, I'm gonna make a copy of the original vertex buffer. Therefore, vertex buffer, we call it here buffer, is a copy of the original one. So let's make it a vertex. Why is it not working? Vertex buffer and sender. So we simply use the sender, which over here it sends the original vertex buffer into this method, and this method has not a parameter object sender, and we take this sender and put it into the buffer. So we kind of have created a copy of the original vertex buffer, and or actually, yeah, and here verts is new custom custom vertex position colored. Here we set the array, and we said we want to have 3 vertices. And yeah, now let's just simply create these vertices. The first one, 0 point position, is, and here DirectX gives us a very nice option. It has simply some structures called vector 3, vector 2, vector 4. For 2-dimensional things, we wouldn't use the vector 2, but due to the fact that we want to actually program 3-dimensional, we use the vector 3, and that's it. Here, we also have, again, 2 ways to go. if we leave it empty, it would be a 0, 0, 0 vector, or we can actually store already the x value, y, and c value, and that's what we're gonna do over here. So the first vertex should be, I'm gonna set later on that the center of where we are looking at will be 0, 0, 0. Okay, we didn't set it yet, but that's what we're gonna do soon. So we're gonna look at 0, 0, 0, and to create a triangle, if we are in the center of the screen, then one edge of the triangle would be in the middle, but a little bit above. So 1 unit above of 1. So from x, it's left to right is the x-axis, and here we go with 0. Then on the epsilon axis, I want to be 1 above. And on the z-axis, which is actually the z-axis is nothing else but the going into the screen, where my screen would be, for instance, 0. If I go deeper and deeper into our screen virtually, then the z-axis is going to increase. We simply go here with 1. So then also the color information, verts 0.color is, and we can use actually the system drawing colors. And what do we do the first? Let's go for green. The problem is this colors is a system drawing color, and the vertex color actually requires an integer value. But we have there a function in the system drawing to kind of turn the system drawing color into an integer value, and it's called ARGB. RGB stands for red, green, blue, and I think it's the alpha channel, so how transparent something is, a transparent value. Not sure though, whatever. Simply has to work. Okay, that's it. We have defined our first vertex. We need to do this 3 times all together. So the vertex number 1 has, we give it another color, let's say blue. And the vertex on 2, we also give it another color, let's say green, blue, red. Okay, but the position now, okay, the first one is in the middle of our screen and on top. I'm gonna show it with a bitmap. So, sorry for my bad drawing. So the center of the camera where we're gonna look will be in the middle. The first one which we set is 1 to the top. It's in the middle. It's 0, 0. This is 0, 0, and we go 1 to the top. You know. The second one will be we go 1 to the bottom and 1 to the left. It's over here. And the third vertex is 1 to the bottom and 1 to the right. Actually, first to the right on the X and then 1 to the bottom. So, and here we have then our beautiful triangle. Okay. Well, let's leave it open. Maybe we need it. So what did we say? 0 and 1. Then this we set to -1 and -1. It's the left spot. And this one we set to x plus 1 to the right hand side, but also on the epsilon axis on -1. These are 3 coordinates, and that's it. Now we need to actually draw or put this vertex information, this whole vertex, into our buffer. That's what we're gonna do over here. Buffer the set data, the words, where is it here, and what is offset? We set the 0, we started the first, and log flags we defined with none. Okay, everything should be in our buffer. Okay, so we set up our vertices. All the information is here. We initialized our graphics. Yeah. So we go into initialize graphics. At one point, we go to the on Vertex Buffer create. Once it's being created, we have the information of the vertices, and we have them already stored into our Vertex Buffer, into our main one. Okay. Now we actually need to call this method still, and we're gonna do this in the form. Yeah? At one point we have this initialize components. This is the standard stuff made by Visual Studio to create the actual form over here. So this one is the first thing, and right after that we're gonna put our initialize graphics. Oh my god. So, and here we go. So I mentioned it briefly a bit earlier. We're gonna look at the center, which will be 0, 0, but we did not specify it yet. To be able to work with our three-dimensional world and to look at this whole world, we need to set up a camera. And this is what we're gonna do now. Private void setup camera, and in the setup camera, in the first glance it might be a little bit complicated, but it's actually not. We just need to know the main object to go is our device, and so we tell the device our camera, and it's actually not called camera over here, but device dot transform, and here we have the projection. That's the first thing. If we set the transform dot projection of the device, it tells how to look into our three-dimensional world, like how to do that. And the projection and all this three-dimensional thingies, we to work with points and spots, we work with position vectors. You know, a vector can be, as you know, it's kind of like an arrow from one to another point, so a directional vector, but a vector can also be a position vector. Yeah, so simply it's pointing from the 0 point towards this to give us a position vector. But to actually work with a three-dimensional room, we need something higher, something bigger, something which can store much more information, and that's a matrix. And DirectX also provides us this information. We're gonna create a matrix, and not just any matrix, but we're gonna need the perspective matrix. And I'm gonna choose this one. It's the perspective field of view, left hand. Another option would be here right hand. The left hand, right hand is simply the in which orientation the Cartesian coordination system would be pointing. So we just choose for a left-hand system, and that's it. So our field of view is required to be a float value. So we actually cast it into a float value. And what do we cast? We cast math.pi. Why? Because math.pi, I think, is 360 degree or 180 degree. I don't remember. And we just do a quarter. I think pi quarter is 90 degree. Am I right, or am I don't know. It's long ago when I had to learn this at mathematics. But simply we are working with the pi to go around the whole circle, and I think pi quarter should be 90 degree. So, and this is the field of view of y. Then the aspect ratio. Here we tell our projection of what is actually the ratio to look at. And the ratio to look at, it's quite simple. It should be, because we draw everything into our Windows form, it should be kind of the ratio between the width and the height. And that's it. So our ratio, we're gonna send this dot width divided by this dot height. Okay. What's the next parameter? The next parameter is the set near plane and the set far plane. You can just simply imagine we are looking now into a direction. No, at the moment we don't, because we didn't set it yet. But in front of our camera into a virtual three-dimensional world, we have a we have a distance to look at, and the set near plane is where we actually, at what virtual unit we start drawing the things on our screen, and we actually start at 1.0, and the set far plane will be how far we gonna look, how far we gonna paint everything, how far we can see. And here we wouldn't need it that big now, but for later on we just set it to 100 virtual units, I don't know, or 100 meters or whatever. It has one certain unit, and this is the way to go. Okay, let's quickly create now. We have now set the projection, how the camera actually looks, but we did not define where is the camera placed and where does the camera actually look at. And this is what we're gonna do now. Device.transform, that's again, and here we have the view. And the view will be a new matrix, not math, matrix. Dot, and we have a look at somewhere here, look at, and again we could choose between look left hand or a right hand system. Just let's stick with one. The left hand is, for me personally, just the more logical, the one which I used at school and so on. So look at in a left hand system. So what do we have here? And here we simply need three vectors. The first vector gives the camera position, where in our three-dimensional world we want to have our camera positioned. The second one is, where does the camera look at? What's the target of the camera? What direction is it pointing? It's not in what direction it's pointing, but where at it's pointing. And the camera up vector is simply a standard value which we set up. So first one is a new vector 3 and defines the camera position. We just go somewhere into our screen now with our position, and so we have 0, 0, and let's say 5 and 0. And it doesn't actually matter wherever we want to be, but this should work. So then the next vector is also vector 3, the target, but the point that we actually just look at we want to look at 0, 0, 0 on all three axes on the exactly 0 spot, and that's why we just leave it empty. I mean, we also could write in 0, 0, 0, doesn't matter, it would be the same. So we look into the vector, new vector 3, and this one is simply 0. This is a standard value, which we're not gonna touch. Actually, we delete this. So it's actually a float value, but yeah, it looks a bit more neat if I just put in integer. Still will be transformed into a float. So the setup camera. What do we else need actually in the camera? So far, we're gonna need something once we started the whole thing. Let's see. What would happen if I start the program now? Yeah, exactly nothing, because here inside here of our paint event, we have our loop, whatever will be painted. But we have set up now everything, the device is set up, and so the first thing which we then actually do in our paint method, in our endless loop, so to say, in our endless painting loop, is we always clear the device. So the device should be totally empty of any information. Clear. And what do we want to clear? We can set up here, it's the clear flags dot, and at the moment target is the way to go. Later on, when we actually implement a set buffer or a depth buffer, we also need to clear that one. But at the moment, just the target is all what we what we need. So the second thing will be color. We define now here with what color the whole thing should be filled, how to fill our device. And one very famous color always used in a lot of these DirectX tutorials is this cornflower blue. And I go with that as well. So, and yeah, then the sep depth we don't need. We have no information in the stencil. We just set to 1. Yeah, just as a standard value, and that's it. Next, no, actually, wait, we set to 1 and stencil to 0. So here we go. Now we have cleared the whole device. So the next thing which we now have to do is to set the camera for the device. Set camera, and that's what we're gonna do. So we clear the device, we set camera, it jumps up here, it sets up our camera with our field of view, with our look at everything, and very dynamically, so we can change it easily. As soon as the camera kind of changes from one position to another, which we didn't program yet, it will be updated instantly and repainted onto its proper position. So setup camera is the first thing to call. And now another thing would be if we would have created a light to set up the light, but we skip this now simply because it would require some more stuff. We can't simply set up a light because our vertices have no normal vector position, and you would need the normal vector for each vertex to be able to let DirectX calculate the proper light and shadow, doing the proper math. So But the next thing what we're gonna do now, and here we go, it's the device. We begin a scene. We just wanna draw now some kind of scene, begin scene, and here we go. And at the end, in the middle, we're gonna write now something, but at the end will be then the device. Yeah, you guessed it right. End scene. Okay. So, and in here, we want to draw now something. We're going to create a scene, a picture. Yeah, just a picture on our device. And the picture which we want to draw will be our triangle. But we actually only have the vertices. So now we need to set our device to tell the device here now the vertex format. Vertex format, and the vertex format is, yeah, custom vertex. Where is it? And we have it positioned, no, not equals, position colored, and the format. Sorry. So, and that's the next thing, the stream source. We need to tell now the device where should it get the stream source, like what it has to put on the picture, on the screen. Stream, where is it? Stream source, no, set stream source, that was it, set stream source. So we need to set the stream source. So what options do we have? The stream number, this is the first stream, so 0. This is the vertex buffer, what vertex buffer, from which vertex buffer should it receive the data. It's our standard or default vertex buffer, which we set up earlier, which we filled already with our data. So here we use this data, and offset in byte we start at the very beginning, so we have no offset. So it's also 0. And now we paint all three, all vertices into our device. And now we would like to do something with these 3 dots, which are now in there. And therefore, there is a core function, it's called device. We tell it now how to draw things, and we use the draw primitives. Now here are different functions which we could use. We just use the draw primitives function, and yeah, primitive type. The first thing is, yeah, primitive type. Let's see what we have. Primitive type dot, yeah, and here we have 6 options. And it simply says how does it connect the dots with each other. So do we want to have a point list, or do we want to have a line list? Line list would be if we would have 10 vertices, the first one with the second would be connected, then I think the third with the fourth, then the fifth with the sixth, or so. I didn't know exactly now. I need to, the line strip is, I think you have one vertex as the center and it connects somewhere else, then the point list, the triangle fan, triangle list, and triangle strap. These 3 would draw triangles, but in whatever way we go with the triangle list. So simply the first vertex is being connected to the second, and the second vertex is being connected to the third, and the third vertex is back connected to the first one. And then if we would have even more, the fourth vertex would be connected to the fifth to the sixth, and the sixth back to the fourth. And so that's what triangle list is actually doing. What's the next parameter? Start vertex. Yeah, of course we start at the 0 index. And primitive count, we always go up by 1, you know. So we go from the 0 vertex to the vertex with the index 1 to the vertex with the index 2, and always so on. Okay, that's the draw primitives function. And now our device actually drew already the triangle. And yeah, what do we need? End scene we have. And after the scene is being done, here we created our scene. After the scene is being done, we send this whole thing now to our Windows form. Device dot present. This will send it now to a Windows form. So, do I have everything? Initialize graphics, setup, camera, vertex buffer, paint, variable set. What did I forget? Most probably we'll get an error. Yeah, this one. Load a log DLL. Yeah, it doesn't like it, so I just make an exception over here. It has some kind of a problem, I have no idea. Ha! Here we are. So I set this exception and I draw now this whole thing, and yeah, we have our triangle. But although we actually set it up with some certain colors, it doesn't draw the colors. It's pitch black. Why does it do that? It's simply because our lighting, we have our light turned on. It's on standard always turned on, and therefore it would need to be able to calculate the lighting properly. It would we would need to set up the normal vectors, but we're not gonna do that, so we simply just turn off the lighting. What am I doing? So the bitmap I don't need anymore. So where's the lighting? We turn it off in our set camera here. Device. We need to render state. It was here. It is render state. We need to set the render state, and here we have the option lighting, and this is false. It's usually set to true, and let's check. Ha! Now we have it in true color, and that's it. You know, if I go too small, it can't. I don't know from there. But yeah, that's our first triangle, and it is actually in a three-dimensional room, but we can't see it yet because our camera is locked still. Just to prove you that this whole thing is actually in a three-dimensional room, we can, where we set the camera, we can create another matrix and device transform, and here we're gonna transform the world, and we give it a transform matrix. So what we need, a matrix, and here let's see what we want. We don't just want to transform the matrix, but we want to use a function which actually lets the matrix rotate. We have a different rotation quaternion axis, also rotation yaw pitch roll. This is kind of a rotation around itself, around all three axes of the matrix itself, but we're just gonna stick with rotating around the x axis. And yeah, for that we only need an angle. Yeah, float angle, and let's just give it an angle. And we're gonna set up here a float angle, and we set up the angle to 0.1 and 0.0, and that's it. So the angle is set to our setup camera, and it's rotating now around the x-axis with the angle of 0. So I don't just rotate it, I just create one out of this whole view. I let it rotate a little bit by this angle, but this angle is 0, so it will not rotate it at all. Yeah, as you can see. But if we would now increase the angle step by step, it would actually show us. And where do we actually increment our angle? We simply can do it over here, because this method is being called by the form paint event, and I told you everything in here between this invalidate and the paint, this will be in a loop, constantly in a loop and rendering over and over. So whenever it's being rendered again, it should it can just increase itself. So simply let's increase the angle by 0.05. I go, because everything else would be too fast. Of course, it's a float value, and let's check. Ha! And it does something, but it disappears. Yeah. And why does it disappear? Because on standard we only see the front side of the triangle. We could change that, or actually we have to change that. Let's change it here with the lighting device, and it's also a render state, and it's the call mode. And call mode, we have here the options of call.clockwise, counterclockwise. I think the standard value is clockwise, or is it counterclockwise? No, I think counterclockwise is the standard value. Another option would be clockwise. And to show the back and the front, and we go with none. So now both triangle sides will be drawn and displayed. And here we go, our triangle rotating around the x-axis. Let's just change here it to the epsilon axis. Let's see how it works over here. Yeah, oh, super cool. A sweet three-dimensional triangle. So yeah, that's our word. That was my first tutorial. Thank you for watching, and see you soon.